promoter is tattling on me. So let's open a project and we will open Learn Angular. And this project is this is the to-do list we worked on a stream. Oh, man, it's been a long time ago when we worked on this one. But it's in a
I don't.
state where we can add some RxJs to it and get some real benefit to doing that.
Nice.
Um,
I'm excited. I'm always having fun with these, but today I think I'm more excited than I have been.
that's good. That's really good to hear because um, I'm excited for today. And to start off, so this is the repo to the code we'll be working on today. The other thing I want to share with everybody is this amazing site called RxJs or RxMarbles. This is probably one of my absolute favorite sites. It has so many amazing things on it that it's just a really well put together site to help you visualize RxJS. And it's going to have images that we can draw on so that I'm not just waving my mouse around or trying to draw things for you. These are actually, they're taking actual operators and they're creating marbles diagrams out of them, which is something that we'll discuss. But in the beginning, let's just talk about what is RxJS? What does it mean to be reactive? Why do we call them observables? Why do we subscribe to observables and things like that? And probably the best way that I've found to think about observables is observables are just streams of something. It doesn't matter what it is. Even our conversations are observable because when we have conversations aren't typically totally synchronous, right? You'll be sitting there listening to me as I speak, and you're getting a stream of, my words, and you're processing those words as they come to you. So you're observing the stream of me speaking. And then when I stop, and then, somebody replies or something like that, that's not synchronous, right? I've stopped my stream, paused it temporarily, and then when somebody speaks to me, I'm observing their stream. So it's this reactive style of programming where you expect a stream of something, right? Say you go to a website and you ask for an HTTP response, an HTTP request. You go to that website, you say, hey, I want some data from you. And then you wait and you observe that stream of data until you get the data that you want. And that's reactive style programming. You observe streams of something, and when something happens in that stream, you have something that's observing that stream, and it's going to react to whatever happens in that stream. Does that make sense?
It does. I'm wanting you to give like the elevator pitch for what RxJS is.
Okay, let's do that. The elevator pitch for RxJS. What is RxJS and why does it exist? Rx actually stands for reactive extension. And it was this idea that I can't remember his name. He worked at Microsoft at the time, but he came up with this new way of looking at programming. And to demonstrate his new way of looking at it, he created reactive extensions for .NET. And there are tons of reactive extensions. So if you learn RxJS, you can go and find RxJava or Rx.NET. There are reactive extensions for almost every language out there. And once you understand the concepts of RxJS, you kind of have superpowers because you can move around and understand reactive extensions anywhere. But beyond that, reactive extensions is kind of, well, it is built on top of a well-established pattern in computer programming and architecture called the observer pattern. And the observer pattern says that you will have something that produces events, and any number of things can observe that thing that's producing events and react to them in any way. And you see the observer pattern all over the place. So the really cool thing about RxJS is once you understand how RxJS works and how observers and observables work, you kind of get superpowers and you can move into a lot more complicated code and understand it because the observer pattern appears everywhere. And once you learn to recognize it and how it works, you'll be a better dev, but you'll also be able to architect much more complicated things because the nice thing about the observer pattern is there's this common term in programming called coupling, and I'm sure you guys have heard it. Do you know what coupling is, Brooke?
I actually don't know.
Okay, it's a very common term, and in fact, you'll hear people talk about decoupling or um, looser coupling, things like that. What coupling means is that, say for example, we have a class, right? And the class is a dog, and our dog class has. So let's just say we have this class, right? Our class is dog, and our dog has a name, and our dog can bark. And this is our dog class, right? Um, when we talk about coupling, uh, and let's give our dog class a constructor so that we can give our dog a name from the constructor. And we'll just move the name into the constructor because we can do that in TypeScript. So now we've got our dog class, right? When we talk about coupling, let's say we create Spot, and Spot is a new dog who has a name of Spot, right? And we do spot.bark. Well, in this case, Spot is coupled to the dog class because we've said Spot is a new dog. And so this variable Spot relies heavily on the dog class. And in fact, if we add, for example, a number here, and we do so now we've trained Spot, and Spot can now bark the number of times that we tell Spot to bark. Because we're coupled to Spot, we've broken bark. And this is the notion of coupling, where something is so tied to something else in our code that if we change that other thing, we break everything that relies on that place in the code. Does that make sense?
Yeah.
So the point of things like RxJs and the observer pattern is that by making streams or something that we can observe, we can break a bit of coupling because our observer, really, we're just looking for our observer to emit something, and we know what that something is, but we don't care about the internals of the class, right? If we change an observable stream, anything that's subscribed to it that is still getting the same values that they expect isn't broken. Whereas if we change the internals of this dog class, we break Spot. And that's the notion of coupling, and one of the reasons why the observer pattern is powerful. A lot of the patterns in programming are to try and break that coupling to make our code easier to change so that we're confident in making changes, right? Imagine that this dog class is used throughout 400 files. Right now, this small change to the number of times that we bark is nothing. But, if we have to go and change it in 400 files, now our change is painful and we start thinking, well, maybe we don't really want to do that, and our software starts to suffer. We're hesitant to make changes because those changes are so painful to make. And one of the ways we can make changes easier is by decoupling. Let's get into RxJS and observers and observables. The nice thing about observables is it's something that you can watch in your code. And so when you're calling subscribe on an observable, you're telling that observable that you want to be notified when something changes. You can have any number of things subscribed to an observable. And we'll see that in the future when we work with things like the share operator and things like that. That sometimes having multiple things subscribed to a stream can cause side effects that you may not want to have happen. Let's talk about from the very most basic, how do we create an observable? What's the easiest way to create an observable? And the absolute easiest way are um, these four methods or operators creation. Um, they're not really operators. They're functions that will create observables for us, and we'll take a look at from.
So I'm going to ask a question here that's going
Sure.
to kind of put a pause in what you're
Hmm.
going down there. I think like one thing I feel like when I was first learning about RxJS that really helped me was to kind of get a more of a visual of kind of the why. You know, like having an understanding, more of like a
Yeah.
real world example of I had this app and I
Hmm.
was using it to do X, but then I decided to bring in RxJS because it enhanced my ability to do blah. You know, like it
Yeah.
made it so that I
Absolutely.
could do blah. But do you have an example of something where RxJS made something better? And I don't know, I
Yeah.
just feel like if there's that example,
Absolutely.
it might help. Cool, cool, cool.
Absolutely. Let's talk about where RxJS has made something simple. So the very first time that I encountered RxJS was way back when I was working on an application for an auto auction. And this has been years ago. This was a Windows desktop application.
Nice.
And they used it on a tablet, and they would go out into like spotty wireless, and they would go write condition reports for vehicles. And a condition report for a vehicle, if you don't know anything about auto auctions, when a dealer or somebody brings a vehicle to an auto auction, there's somebody who's been trained to inspect the car, and they walk around the entire car, and they know every piece of damage and give an estimate for what it'll take to fix. A lot of auctions now apply AI to that, and they'll give reports to dealerships that say, hey, if you make these fixes, your car will sell for X more. And this is the cost of the fixes, and this is how much more you'll make if you make these fixes, which is really cool. But it relies on somebody, out in the heat or cold or rain or whatever, out walking around the car and noting damages to the vehicle. Well, one of the things that people were asking for was the ability to save settings. They were having problems where the battery would die on these devices. And when the battery died, they'd have to restart the application, and they wanted everything to be back the way it was. When they popped on a new battery, started everything up. And I was having trouble because they'd be resizing windows, they'd be moving tabs, and there'd be all these crazy things going on. My naive implementation was anytime a window resized, I wrote that to the settings file. You have to realize that when you're resizing a window, you're not getting one event. You're getting, 10, 15, 20 events from the time you start when the window's bigger to when it's smaller, or when it's smaller to when it's bigger. You're getting all these events as people are dragging windows around. Tab clicks were causing hundreds of events. And all of these events were hitting um, this piece that I was using to write the settings to a file to use. And it was corrupting the file. I was just getting way too much data, way too many events were hitting all at the same time. I was like, I don't know how I'm going to handle this. There's just so much going on. And if I debounce the resize, then I'm not guaranteed to get that when they change a tab. And if I debounce the tab and the resize, how do I join these two together? And then when they do this, how do I join all of this data together in a cohesive way that I can write out the settings and the changes? Um, and so I was doing research, and I came across reactive extensions, and man, I could create a stream of window resize events, and I could create a stream of of tab events, and I could create a stream of button clicks, and I could create a stream of other settings changes. And when those settings changed, I could join all of those streams of events together, debounce when they happened, and I could control how often I was writing to the settings file. And it was mind blowing at that point in time that I could take all of this stuff that was so difficult to deal with and just create a stream of events that told me, hey, you need to save now. You need to save now. And not only did it say you need to save now, it would give me deltas of what I needed to save. So I wasn't having to do all of these calculations, and it just simplified the project so much, and it was so powerful, and it was incredible. And that's when I fell in love with RxJS. Well, reactive extensions, and RxJS is one of the reactive extensions. Does that answer your question, Brooke?
Yeah, I think it's a great example. I think it definitely helps to kind of give some light. And see, this is where I feel like RxJS is something that scares a lot of people away, because even in your explanation to simplify something to give a better understanding, there's all sorts of terminology that someone newer to either Angular or just RxJS, they may not understand what is an event. And you
Absolutely.
mentioned observables and different terms. And so that's where, like, I'm
Okay.
excited for today, because I think
Yeah,
going
let's.
through these things will help to kind of define each of, like,
Yeah.
you kind of said, like, they might have clicked on something
Yep.
or changed to a different tab. So
Hmm.
those are events, but I guess if this is an intro course
Yeah,
to
absolutely.
it, let's
Let's
define that.
slow
What
it
are
down and
events?
let's define it. And that's why I really appreciate having you here, because to me this stuff seems very basic, right?
Right.
And so I don't know. It's hard for me to recognize the stuff that I should slow down and talk about. And I really appreciate you pointing this out to me. And when Nice says that they are a junior full stack developer and wanted to ask about NGRX. Yeah, okay. Yes, we will be getting to NGRX, and we will be getting to stores, and things like that a little bit later in the stream. And I would be happy to share reading and information that I have about that too. The main reason I want to start with RxJS is that NGRX is built heavily on RxJS. And I think one of the biggest struggles that new devs have when they come to NGRX in Angular is that Angular is built so heavily on RxJS that their frustration just grows, right? I don't understand observables. I don't understand RxJS. I don't understand this. I don't understand this. NGRX sucks, right? That's kind of the line of reasoning. And it can be very, very frustrating. And I get that. Sometimes I get frustrated with things too. And that's where it helps to slow down and dig deeper and figure things out. We'll start with events and what an event is. So an event is anything in the application that we want to react to. It could be button clicks. It could be in web applications. It could be the URL change. It could be router navigations. It could be an error because they entered data wrong. It could, it's so many things are events in programming. One of the tough things to solve in programming is how do we make all of those events cohesive, and how do we respond to them in a way that we aren't writing tons of code over and over again to respond to events, right? The big thing that you hear, and it's kind of become a little bit of a meme in the Angular community, is boilerplate, right? How do we avoid a lot of boilerplate? Um, and RxJS is another way that we can avoid a lot of boilerplate. But to use RxJS, we need to be able to create observables, and there's tons of ways to create observables. Um, if you go to the RxJS API and you just search for from, we've got from event, from a pattern, from a fetch. We can create observables from all sorts of things, and we're actually going to do that a little bit today as we dive into the application, and then we'll start talking about NGRX once we've got a firm hold of RxJS. But I think it's really important to understand RxJS before we dive into NGRX. So,
Another thing that we were talking about before we came on was in it, and it's an analogy. So, Jason, you can share this now or whenever you feel
okay.
like is appropriate. But it was this analogy when I first started learning about RxJS that it was that first click that things finally started making sense in my
Hmm.
head. And I know you said that it's one of your favorite analogies too, but it's the idea of when, because subscribing. Well,
Hmm.
what the heck is subscribing in programming? And so it what this analogy does is give you an idea of some of these terms and things, and it's just comparing literally to like streaming Netflix or some other TV service, and it
Absolutely.
just really makes sense of this whole idea of what is going on with
Absolutely.
RxJS.
Well, and even when you talk about streaming Netflix, right? You're using the term stream. So there's a stream of data, and whatever device you're watching Netflix on is getting that data, and it's interpreting that data, and it's presenting it to you in the form of a show or a movie or something, right? So streams appear everywhere. First, let's talk about subscribing, right? Because why do we want to subscribe? What's the point of subscribing? And a lot of people use the analogy of observables as being a pipe, and potentially that pipe is full of liquid or who knows what, right? Um, we'll use liquid in our example because it helps to understand what a subscribe is. The one thing I really like about RxJS is that Ben Lesh does amazing talks. And if you want to learn about a ton about RxJS, just go Google Ben Lesh and watch any of his talks. He'll talk about all sorts of amazing things. His Q&As are always really good, but he understands reactive programming and observables really well. Getting back to the analogy, let's say we've got a pipe of water, right? Well, let's just say we've got a pipe, and that pipe is able to contain water, but there's nothing in it. And why is there nothing in it? Because we haven't put anything in it. So we connect that pipe to something, and water is now in the pipe, but that pipe does us no good, right? Because we're not getting anything out of the pipe. And if we think about it in that way, then a faucet or a tap or a spigot or any of the things that you would add to a pipe to get water out of it, a sprinkler, those become our subscribes, right? And until we subscribe, that pipe really doesn't do anything for us. Um, and maybe we build the pipe ourselves, and we add all sorts of stuff. Maybe we want to turn um, maybe we want to turn our pipe of liquid into a juice or something, and so we've added all this special machinery onto it. And we can think of these special machinery as things like the operators, right? Where we're changing from one thing to another, and maybe we're bringing in other things to add to our pipe so that our pipe of liquid becomes something different than what we get into it. But that pipe does nothing until we subscribe to it, because it makes no sense for that pipe to do anything until we're ready to bottle it or put it in cans or do whatever we want to do with it. And so those subscribes are the way we get things out. And one of the big things that we talk about when we talk about RxJS is this notion of hot observables versus cold observables. And what's the difference, right? And the technical definition is that hot observables are always emitting regardless of subscribers. They could have 0 subscribers, they could have 100 subscribers, they're always emitting. Cold observables never do anything until they get a subscriber. And once they get a subscriber, then they're going to start emitting and producing value. Um, and Brooke brought up one of my favorite analogies, and I should have looked it up so I could credit the person who came up with it, because it's an amazing analogy and it really just kind of made it click for me. But you can look at cold observables very similar to things like Spotify or or Netflix or Hulu or, any of the streaming services that provide some sort of content, right? Those services do nothing until you go and, on your phone, you turn on Spotify, or on your computer, you go to Netflix. And as soon as you turn it on, immediately it starts streaming your favorite show, your favorite music, your favorite movie, who knows what, right? That's a cold observable. Because when you are listening to Spotify or you are watching Netflix, you're getting your own individual version of that. You can rewind it, you can fast forward it, even like with YouTube or other video services, you can play it at a faster speed or a slower speed. You can pause, you can stop and come back. All of these things you do, and you doing that, even if I'm watching the exact same show as you, it's not going to affect me. That's a cold observable. Um, and there are ways to share cold observables so that um, there are ways to share them so that you're not, for example, with HTTP calls, you don't want to make that call every time you subscribe in a page. So there are ways to make it so that you can share that response, and we'll talk about some of those in the future. A great example of a hot observable is this stream. I started streaming at 2 o'clock, regardless of however many people were here. You guys can rewatch the stream, and that's giving you your own version of the stream, regardless of how many people come and go, or whatever happens. I'm not going to stop what I'm doing. It's not going to affect me. And the stream will run for a certain amount of time, and then it will stop. People can join at any point in time, and when they join, they're going to get the next events that I'm doing in the stream. But to get previous events, they're going to have to go watch a replay or something like that. But the stream itself is just going to keep going, regardless of how many people are there. If somebody walks away or if somebody stops watching or who knows what, it's just going to keep going until it's time to stop, and then it stops, and that's a hot observable. The stream just keeps going. It doesn't stop. If everybody stops watching, I'm still going to keep talking. Or if I get 1,000 people watching, it's still just going to keep going the same way. The notion is that it's something that you can consume that's always going, and
Right.
regardless of when you join, it doesn't change. The nice thing about observables is that you can subscribe at any point in time on a hot observable, and you'll just keep getting the same values, right? An idea of this is maybe you have a game loop. The character moves, and the inputs from the player are always going to be happening regardless of other things, right? So you may want to watch when a weapon fires if there's an upgrade on the weapon and you want to apply that weapon to the upgrade to the weapon. But the player's inputs are a hot observable that are just going to keep going. Um, uh, Cold observables are things like in programming terms like HTTP calls. You don't want to set up an HTTP call and have it immediately fire off when you don't have anything ready to listen to it. That's kind of the importance of the two. There are some things that you don't want to interrupt, the user doing. You don't want to interrupt their clicks. You don't want to interrupt user input when they're playing a game. That would be really frustrating. But there are other things that you don't want to do right away because you're just wasting resources.